Okay, welcome everybody. We are ready for another monthly show and tell. So if you're new to our show and tell um, experience here, it's a little bit different from our weekly roundtable in that our show and tell is meant for showing internally stuff that we've been working on, things that we're ready to show, things that are demoable. It's kind of a look over the shoulder of it's kind of a look over the shoulder of what's been going on and what people are working on, what they're building. It gives you a little bit of a chance to have a sneak peek as to what's coming up. Now, what's unique about this last month was we spent a lot of time preparing for and speaking at and participating in the Ethereum DevCon conference, DevCon 4, that happened in Prague, Czech Republic, just a couple weeks ago. So because of that, there's maybe some different type of updates, or maybe some folks were working more on conference talks. So it wasn't as productive a month from the perspective of shipping code, but very productive for our project and for Mainframe in general. So Megan, why don't you start off by showing us the website refresh? Thanks.
Sure. So it was mostly just design changes that we implemented recently here to reflect some newer content and wording and such. So a lot of copy change and design change mostly. So here's the homepage, which was a major change here. And we've also introduced a developer, like a way of collecting developer emails, and just a little form to talk to people who are interested in using Mainframe. Otherwise, it's mostly design changes. I think actually the only major ones here are team and the Y page. Here. And then the other major change was, I don't know how much people know about the staging website, but we also have a staging site where you can edit like your profile on the team page and those kinds of things. So we also added a UI for what will be an events page that we'll have live once we have, I think, some more events fleshed out. The design looks a little weird here right now because there aren't a lot of events here, but the design is implemented and it should look something more like this. But yeah, just like a simple UI for interacting with, or so that, someone like Pete or Austin can edit and upload the events. So yeah, I think that's everything. Maybe Diogo, is there something I'm missing, or we're all good?
Yeah, just we have now like a focus on getting more developers registered into our website. So the focus on our website is getting people to get registered on the developer form. So this is something we built as well. Developers are now able to register there, and we're gonna keep in touch with them with the data that we get from them. So that's just it.
Was one of the major changes a shift from showing our platform as a communications platform and now more of a DApp platform? Is that also the messaging change?
I think so, yeah.
Yeah.
Cool.
So yeah, I think that is all for me.
All right, so let me just share my screen here. And so I'm going to start out by just showing what this DApp does in terms of code. So at the core of this DApp is a contract called election. And this contract takes advantage of some of the Zeppelin features, the features of the Open Zeppelin project, which the one feature we're using here is the one that lets you identify who the owner of a contract is and provide and allow them to have special access to call certain methods in the contract. So only the owner can call certain methods. What this does is allow us to basically let the owner approve certain people to vote for certain candidates. So this is an elections contract. So the owner, the way the workflow in this contract goes is that the owner of the contract can add as many candidates as they want to here with the add candidate method. And some of these other other methods are just for convenience in enumerating and listing the candidates that are already there so that they can be displayed in a web interface. And one of the other things that the owner of the contract does is approve certain accounts to be able to vote. So if we added this feature because basically anybody can create an Ethereum wallet, and if they wanted to, without this feature of approving certain voters, someone could rig the elections by just creating a ton of wallets and voting from each wallet. So what we've done here is allowed the owner to only approve certain accounts for voting. And then we have some other convenience methods for enumerating the list of voters so they can be displayed in a web interface. And then finally, we have functionality around the actual voting itself. And this basically just lets a candidate who has already been approved vote for somebody. And if everything passes and the voter hasn't voted already, this basically increments the count of how many votes a candidate got. Now there is one potential weakness in this contract that I should maybe point out, which is that we're not doing any we're not doing any safe math in here. So we probably should add the Open Zeppelin support for safe math as well in this increment, because it's possible if a candidate got too many votes that they could, like, their count for how many votes they got could get reset to like a negative number or to 0, depending on whether it's an unsigned or signed integer. That probably wouldn't happen because it would take an enormous number of votes, but I just point that out. And then finally, there's a method here for seeing how many votes a candidate actually got so that we can display that in the web interface. And so we have this web interface, I think, deployed now. Let me just open this up and share it. And
yeah, it should be deployed to the address I just pinged you.
Okay, let me just share my my screen, or stop sharing this one and you share. Here we go. And Diogo, being the overachiever that he is, has bothered to translate the DApp because it was only in Portuguese before. So so now we have this DApp in English, and what you're seeing here is so let me just double check here. I've got to make sure that my MetaMask in this browser is the right account. So right now, Diogo, what I'm seeing is that I'm not recognized as the owner of the account, even though I believe that my account should be the owner of this contract. So basically, this DApp has a hard-coded address for where the contract has been deployed in the Ropsten test network of the Ethereum network. And so it knows that I'm the owner of the DApp, and because it knows I'm the owner, it gives me this little interface where I can approve voters. And so Doug has pre-populated a few wallets with funds so that they can participate in the election. The election doesn't cost money, but each transaction costs like a small fraction of a penny. And so anyway, he's approved these. He set up these voters. You saw that there were a couple of accounts that were duplicated here, and that's just because someone can request access multiple times, and when they do so, we're not keeping track of duplicate entries there. So sometimes that happens. We could probably improve this contract by fixing that. But I'm going to approve all of these voters. And because we're on the test network, every transaction that you run takes like a few seconds, even up to a minute to complete. So the interface is a bit slow. There are some test things that I was working on last night to try to speed that up, like running it on something called Ganache. But that was giving me a little bit of trouble, so I decided to just run it on Ropeston. Any moment now, we should see that those voters were approved. And while we're waiting for those voters, I'm going to add some candidates to our list of people we can vote for. We need a female candidate for sure, so we'll add somebody else as well. Here we go. Who do we have so far then? We'll just wait for those transactions to go through, and pretty soon they should show up.
I think there's some dialogues that are popping up. There's MetaMask dialogues that are popping up that don't show.
Oh, that's right. Because I'm only sharing one window, we're not seeing that. Let me share my whole desktop. Okay, so we've got 4 candidates. There was one other member of the Three Stooges who only appeared in a few episodes. I think his name was Shemp or something like that. But so anyway, we'll add one more, and you can see the MetaMask this time, right?
Yep.
So we'll hit confirm. And as you can see, the candidates for this election are far more qualified than any of the recent ones we've participated in. So at this point, we have little zeros next to these candidates. Maybe you can see that better now. And it looks like somebody has already voted for Lucille Ball. So the approved voters are now able to vote. And as they vote and the transactions are confirmed, they basically should show up here. And it looks like I'm looking at Doug through my office window, and he appears to be voting feverishly. So we will ignore the fact that there's only one actual human voter in this election.
I am voting as well. So.
Oh, Gioco's voting as well. Good. So no, right now we don't have any clear winners. We need one more vote for one of the candidates who's got votes already. And then I think, without further ado, I'll turn the time over to, well, before I turn the time over to Diogo, let me just do one other thing here to show you guys something kind of important, I guess, when you're doing your DApp development. So this is in the process of being improved, but right now, when you write your tests for your dApps, it's kind of, so when you're testing an Ethereum dApp, or I mean any number of dApps for that matter, but Ethereum has this problem as well as other platforms. The error messages are really uninformative. So like all you get is like something broke, right? Something failed, or sometimes the error message isn't even, it leads you in the wrong direction. So I have a series of tests here And I can just open up my little thing here. I'll run them for you. But if I go to oh, I need to be running Ganache as well. Oh yeah, good. All right, so so what I've tried to do in these, as I was testing this contract to make sure each of those methods worked, I really had to focus on one little piece at a time and try not to test too many things at once. So very meticulously, very methodically going through this and making sure I was just running one little command, setting up enough data to test that one feature. And it can be challenging because, like I said, if something does fail, you really don't get an informative message. Now, there's an Ethereum improvement proposal that will improve that and hopefully allow you to specify more clear error messages when things go wrong. But that's not widely available yet. So anyway, just a little tip there. This shows kind of the tests that I wrote for the contract that I just showed you guys. And then I think now, let's see how we're going. Lucille Ball won the election so far. And then I guess we could add a feature that like would allow the owner of the election to declare it over or something, or would start the election at a certain block height and then end the election at another block height. So those are some things we could do to improve. But Gioga was the one who took the contract stuff and tied it into the web interface. So I thought maybe he could talk a little bit about how he did that.
Okay. Can you guys hear me?
Yep.
Okay. So yeah, I think I'll share my screen as well. Okay.
Yeah, you might want to just increase your font size a little bit.
Yeah, definitely. So just to give some overview, we used React to build this interface. We use React for most of our UI in Mainframe, so we kept using it, and we also used Material UI, which is a UI library, very simple to use, that is built with the material design from Google. So they have a bunch of React components that you can just start using to build your app, your web app. So we used both of these, and we also used a very good feature from React 16 that is the context. We always had context in React, but it was always called as a testing feature, but now it's production ready. So we are using it to control the whole app. So we can actually plug only one React component to the Web3 library that is used to connect to the Ethereum network and to the smart contract. And later, Adam can give some details on how this is being connected. But so it was very easy to build it, because all we did is we created this context component that uses the create context method from React 16, the latest React release. And we create a context that injects properties to every component we want to use. So in this app component, we created all the methods that will connect to the smart contract itself. And then, so the batch approve that will approve all the voters, the request approval method, add candidate, approve, and vote, for example. And we just use this provider that is generated by the React context, passing all the methods we need. And this will inject as properties in every component we need to use them. So for example, we have the admin area here. That is a simple component, and we wrap it with the apply context method function that was generated from React context. So it will just inject all those methods as properties for this component. So we can use them easily inside the component without needing to worry about anything else. So for example, we are calling this.props.batch approve. So we only take care about these UI here, and the UI will call the method, and everything is done on the admin, on the app component. So it's very easy to componentize. How do I say that? Component. To turn everything into small chunks of components, so we can easily test it and fix errors and reuse it anytime we want. So this way we were able to create the UI in a very simple way. I also used the context to translate the depth. So I created a simple JSON object with all it was a very simple way to do it. So all the messages that are going to be showing on the UI, and we can create any language we want, can build it in any language we want. And for example, if I want to change it to Portuguese, I can just change it here, and I can add it as a feature on the app itself, and everything is translated right away. So this way I can easily add and remove features and messages and everything. So yeah, I think we used a bunch of good features from React to build this simple dApp, and it was very productive because we were able to make it ready very fast.
Yeah, I just want to thank Diogo for his help with that. So on our trip to Brazil, like I was getting this ready like the day before we left. And then like while I was on the plane heading down there, Diogo was getting the web app done. And Adam also helped us quite a bit. So thanks guys for helping on short notice. But this little dApp is kind of a nice example of how to build a dApp. And I think in next steps that we might want to do for other meetups and demonstrations, we might want to deploy this to mainframe storage or something else so that we could show people how to like make this dApp more unstoppable. Because right now it just communicates with blockchain, and it's being hosted from some decentralized or some centralized location. So that's kind of the next logical step that we think we might do when we go down to Brazil in a couple weeks. So I could maybe use some of your help to create a dApp manifest for this and deploy it to Swarm.
Nice. Yeah, I think it would be nice if Adam could give some tips on how he connected to the Web3.js library as well, if we have time.
So yeah, we use Web3.js to interact with the blockchain, and we take a Web3 provider that's provided by the MetaMask plugin and hook that up to our Web3 instance. We also provided Infura URL, which is the service we use to communicate with the blockchain. And then yeah, it's just a process of sort of formatting the transactions instantiating a contract, which is linked to a contract address. And then the Web3 framework will like handle the requests for you. So any requests that are writing transactions to the blockchain, that would actually forward onto MetaMask for sign-in, and then onto the blockchain. And if it's just reading data, then there won't be a transaction, and you'll just make the request straight to the blockchain. And then you've also got the listener once a transaction's been submitted, and it'll listen for new blocks coming in, and any new blocks that have state changes related to your transaction, it will alert you of events, and then you can also then go and alert the user and update the UI, etc. Yeah.
Cool. Great job, everybody. I think that was a interesting demo. Adam, do you want to just keep the mic and talk about and demo what you've got with wallets and transactions?
Yeah, sure. 2 seconds. Okay, can you see that? The launcher? Cool. Let's get rid of that. Okay, yeah, so just gonna walk you through some of the functionality we've added for around wallets and like supporting Ethereum transactions in our apps. So I'm just gonna unlock our vault here, and just in sort of the onboarding process, if a user, or we recognize a user doesn't have a vault, doesn't have a wallet yet, we can provide a screen here to allow them to add a software wallet. The daemon currently supports 2 types of wallets, software wallets and hardware ledger wallets, but the UI here is only offering the creation of software wallets, specifically like HD wallets. So I'm just going to go ahead, create a wallet, and once the wallet's created, the user will be shown the address of the wallet and the mnemonic phrase, which is used to restore that wallet. Okay, so let's continue. And I've got a basic payments app here just to demonstrate some of the possible functionality. Okay, so here it picks up my account, and it's going to load the ETH balance. And then we've got a couple of different functions of sending Ether or sending ERC20 tokens. So if I want to send some ETH, so we have sort of a few hops that a transaction has to make from an app through to the daemon to the blockchain and back again. So apps are sandboxed, and they're contained within like this trusted container, which is UI that Mainframe controls. And so the trip a transaction or request will make is it will go from the app to the sandbox container, from the sandbox container to the launcher process. And then when it gets to the launcher process, requests are checked against the permissions to see if that request is restricted and needs permission from the user. And if so, that request will then get bounced back to the containing window and display the appropriate UI. In this case, it's signed transaction UI. So similar sort of style to MetaMask. We're going to say, this is a transaction this app's trying to make. Are you happy with it? I'm just going to decline this one just so we don't have to wait for the transaction to finish, but I'll show you another transaction in tokens. And then so here you can see developers get an error message, which they can display however they like in here in a not very friendly way. So yeah, so tokens, we can provide a token address here.
Hey, Adam.
Yeah.
One question I have for you is, can you describe in more detail the kinds of things that the sandbox does to sort of protect users more, or whatever additional sandbox features it has?
Yeah, so the sandbox doesn't allow the app to have any access to the underlying node process or to the file system, etc. Any interaction with those levels has to be done over JSON RPC and over like communications that we control. So we can catch any requests or all the requests that we allow and then handle them appropriately, and put this permissions layer in the middle.
Yeah, I remember too that Dwayne had done some work on preventing inspection of certain sensitive elements in HTML. Is that also part of this sandbox?
No, so what do you mean? As in the developer?
So Dwayne had he was doing some experimental work on preventing someone from watching a text field if someone was typing sensitive data into the text field or something like that. So that we could prevent users from introspecting on identity elements that we didn't want to give them direct access to.
So
Do you mean developers or users?
This was a web component. Yeah, at the time it so far has just been for users to be able to select some user from the contact list and prevent the DApp from knowing, being able to read the user's name or any other information other than present that back to the user as, yes, you selected this user in your contact list. Yeah,
for sure. That's it's definitely something we want to get in there, but it's not something the sandbox handles right now.
Okay. Yeah, thanks. Sorry for the interruption.
No worries. Okay, so just looking at the tokens function, here I've added a token address, which is an MFT token on the Ropsten network, and an account I want to send the tokens to, and the amount of tokens. And you see this time when I press send, it sort of processed the data and it can understand that it's an ERC20 transaction. And so we can display the data in a more friendly way. We can give the user more information about that its tokens is trying to be transferred and where someone's transferred to. So we've sort of got these helpers where we can add any common contract ABIs and display the UI here in a better way. So if I'm just going to accept this transaction here, and yeah, it's going to spin for a while now, so I might want to cut this out. But yeah, basically, we're going to wait for some feedback here from the transaction once we get confirmed TX hash. Well, I think that pretty much covers it anyway. I didn't know if there's much else to discuss or anything. So is there any questions or anything I can expand on?
Yeah, I have a question. So
go ahead, Diogo.
There you go. There's the confirmation.
No, I was just going to ask a simple question. So this is going to be like the payments dApp is supposed to be one of our mainframe dApps, right?
No, this is just like the very basic functionality to show what is exposed right now from our APIs. I don't know how we want the payments app to be eventually.
No, yeah, I mean, but if I want to build a dApp that needs payments, needs to send payments, so I would be able to go through this process without really building my own UI for sending payments and everything, right? Does that make sense?
So you're saying we could have reusable payments component that other developers could use? Is that what you're getting at? Or?
Yeah, inside Mainframe OS. So would the developer need to build their own UI for sending payments, or they could just use Mainframe OS for that? That was the question, basically.
Yeah, I suppose that's something that's open, as a possibility. It's not something this right now. Right now, all we provide to a developer is a web-free provider, which has a few the few essential interfaces with web3 that are get accounts, sign transaction, and send transaction, and they just filter the different requests through to the daemon and back again. But this gives the developer lots of flexibility right now to build anything they want in web3 and familiar with how they're currently doing it in whatever platform they're using. But like you said, yeah, I think in the future we might want to make more helper methods or even helper components like payment components that a developer could just drop into their app and reskin or restyle as they like.
Cool.
Yeah, I was just going to jump in and say that, you know, we definitely want the methods or the UI components for the developer to be as easy to use as possible. Initially, I'm sure they're going to be more difficult until we get more maturity in the SDK. Another thing I just wanted to know is that you know, the payments app, the payments app that we're trying to scope out and get started on, it basically includes a lot of the functionality here, but just adds a layer of like social on top of it. So you're not just sending, you know, payments to a nameless ETH address. You're sending payments to somebody that you have connected with or established a connection, one of your contacts essentially. So it makes it a little bit more human, you know. So anyway, this is great. This is awesome, Adam. It's exciting stuff. It means we're, you know, getting closer and you know, seeing. I can definitely see how this transitions to some of the dApps that we're working on. So very, very cool. Blake, do you want to take a few minutes and show some of your wireframes? Maybe Blake's.
Can you hear me?
Yeah, we can hear you.
Okay, great. Yeah.
While Blake's getting ready, I think just while Blake's getting ready, I think just in the interest of time after that, Paul, do you still want to show some of the Erebos stuff after Blake's done?
Depends if we have time remaining, I think, but it's okay. Otherwise, I can do it next time.
Okay. All right. Yeah. Let's maybe end with Blake and see how. Yeah, we'll give you the last little few minutes here, Blake.
Okay. Okay, great. I'll try to move through this fairly quickly. What we're looking at are wireframes. So these have not been touched and improved by Clement yet. So this is a work in progress view of kind of our current thinking on the product side of how we're thinking about approaching identities and wallet management and contact management notifications at the system level, and then how our go-to-market dApps will integrate with those, and then the functions that they will perform. So we've got quite a bit in here where we've got the identity system panel, the contact system panel, the wallet system panel, the Paymo, the payments dApp that we were just talking about a second ago, some initial ideas there. Onyx Lite, our messenger, what that's coming together, note-taking, a social posting, Twitter-esque social media dApp frame, which still has some details to be fleshed out, and then a file storage dApp, a polling dApp, which I'm looking forward to looking back at this video at Carl's segment and integrating that into here. And then we would have a game that we went to market with as well. And so yeah, so without further ado, we'll go ahead and dive into loading Mainframe OS. So the direction we've gone in our discussions on the product side is away from this idea of being able to kind of switch between different vaults. So now in the wireframes, what you're seeing is that a single machine just has a single vault associated with it. So here I have come back and Lucy Lou has come back and she has reopened the Mainframe OS on her machine. It remembers her identity and she enters her password, and then she goes into the Mainframe OS. If a new installation though for a new user, they'd have a different experience where they would need to set up their first initial vault. And we've still, we've gone back and forth on the vernacular we're using here around vaults or profiles or accounts or, how we're wanting to approach it. But the basic minimum that we're going to ask for is an avatar to make sure that just the experience is always like rich and good for all of the users. And we provide them, the thought is that we would provide them with a good looking avatar by default, and then they would just be able to replace it with something of their own. But we would randomly assign them one. And then they just enter a name and an email address, and they continue, and then we ask them to secure their vault with a password, and they're all done, and they're in. Now, they still have some things that they need to do to fully set up Mainframe OS, and so we're going to try and steer them that way, or try to catch them in different workflows where it's contextual, rather than putting all the hurdles up front at the beginning. At least that's the side of the argument that I'm on. So they would be able to come in and start adding contacts and setting up a wallet for themselves over by clicking on these, but then also in the new user welcome screen, that 0 state screen for the new user, we would potentially guide them through a tour that would have them do those things like adding contacts and setting up their wallet, or they could jump right to those different steps from that screen right there. So a little tip, if any of you come into this Envision prototype and you're trying to navigate it, getting back to this screen, you click the Mainframe OS, and these are all like 0 state links. But then when you go into the different dApps, you'll end up in links that aren't 0 state links. So you'd come into like a mature state. But when you want to get back to the 0 states, come back and go from this screen into the different dApps. So some things we can look at identities. The current thinking with identities is that there wouldn't be this collection of all user data, but that you would collect discrete individual identities, and you would store whatever data you want for yourself in those identities. You could go through the process of creating an identity like this, and we have the option or the requirement actually of having a wallet associated with identity when you create a second identity. So once you have more than one identity, you could see them all there. You could go and you can look at, and with identities, they're kind of a big mini vault, if you will, kind of a big subfolder of the vault. And underneath the identity, you have a group of contacts that are specifically associated with an identity. You have dApps that you have associated one of your identities with specifically, and you have wallets that you have associated with a specific identity as well. So identities are really kind of this big subcategory, this big subfolder of the vault is how we're dealing with it. In terms of this question and challenge around discoverability, we've taken a really simplified approach where when I have contacts associated with identity over here, like professional identity, those contacts could see me in any dApps that I use. Like I connect to them in one dApp, like Onyx Lite, for instance. And if they and I are both over in Paymo, the payments app, then they would just be able to know, and I would be able to know that we're both there, and we can go ahead and connect without having to go through the whole public key entry headache all over again, unless one of those users has their identity set to private in that dApp, in which case their contacts cannot see that they are in that dApp. So we just have a simple binary, private or public, and public just means visible to the contacts that I have personally added to my account already. There's some more interesting stuff. We're running short on time, but in conversations around the studies are outdated math bar. In the social media dApp, there's some interesting challenges that we will have around discoverability and around having ideas that you're putting out into the decentralized web that you want people to be able to find who you don't know, and how do we balance that? And so we've got some ideas there that we'll just have to talk about another time, but that's a quick simplified overview of what we have been looking at. Is there any particular part that people have wanted to look at that you might want to go check out real quick? This wallet section, we'll get some updates based on Adam's demo as well.
Blake, if you would just be sure and share that with all of us on one of our channels, I think it'd be great for us to study it in more detail later.
Yeah, absolutely.
Any overall questions about the wireframes you want to ask Blake? Good. Looks like everybody approves. This is great. No concerns at all. What a miracle. So thanks again, everybody, for joining, and we'll see you next time.